Okay, guys, now in this example, the question is find the expression for the volume of liquid passing per second. Take note of the question. They said volume of liquid passing per second, this V. So this simply means that this V is equals to volume over time. Volume over time. Volume over time. Because the question says find the expression for the volume of liquid passing per second. Now, through a pipe, when the flow is steady, assuming that V is proportional. So, whenever something is proportional, this simply means that it is directly proportional. Since they say V is proportional, you just have something like this, V directly proportional. So, number one, the coefficient of viscosity. This is sign for the coefficient for viscosity. Proportional to this, of the liquid. The radius of the pipe, also to this. And the pressure gradient. They've given you the formula for pressure gradient, which is what? Pressure over length. And the pressure gradient. Now, they then say that causing the flow where P is the pressure, this P is pressure and this L is length. They said that find the expression. This simply means that they ask you to form an equation. So this is the first expression you are going to write. You are going to show the what? The proportionality sign. Directly proportional, directly proportional, directly proportional. You are going to show this. Now, after you've shown this, the next thing you will now write is that you will now notice that since it is directly proportional, then this can be written as, you are going to change this proportion sign to equals to, and once you are changing the proportion sign to equals to, you are going to put K here. K. Then write this R P over L. Now, once you've written this, so what we did here is that we change this proportion sign to equals to. So whenever you are changing proportion sign to equals to, then you are going to put a constant K here. Constant K here. So this K is what? Is a constant. So this constant is coming from what? From changing the proportion sign to what? Equal sign. Now, after you've written this, you will now put each of these parameters inside the brackets. Put this inside the, okay, let me just write it underline. Just say V is equals to K raised to power X raised to power Y raised to power Z. So you are going to put each of these parameters inside the what? Inside the bracket. Once you've done that, the next thing you are now going to do now is that you will now note this V is equals to volume over time. The dimension for volume is L cube, time is T. So this simply means that V is equals to L cube T raised to power minus 1. Now, this sign is equals to coefficient of viscosity. Then you have to know that the dimension for coefficient of viscosity is M L raised power minus 1 T raised power minus 1. This is dimension for coefficient of viscosity. Now, for the pressure gradient, which is pressure over length, we've done for V, you've done for this, then for R, which is radius, the dimension is L. We will also do for, we are going to do for pressure over length. You know this is pressure over length. Are you there? Its own dimension would be M L raised power minus 2 T raised power minus 2. Now that is that. So the first thing we did is that we read the question. The question says find the expression for the volume of liquid passing per second. Volume passing per second. That is volume over time. V. So this V is what? Volume over time. And they say that this V is proportional to the coefficient of viscosity, the radius, and the what? Pressure over length. That's why we wrote this. So we change this proportion sign to equals K. Then we wrote this. Now once you've done this, at this point you will just let each parameter to be raised to power X. You will just put it to be raised to power X, raised to power Y, raised to power Z. So once you've done this, you will now write out the dimension of each of these parameters. Since this V is volume over time, That is L cube over T. So the dimension for this V is what? L raised power 3 T minus 1. For the coefficient of viscosity, its own dimension is this. For the radius, its own dimension is this. And for the pressure over length, its own dimension is this. Okay, so guys, this is the expression, and each parameter has this dimension. Then let us substitute. So this will now be written as L raised power T, L raised power 3 minus T raised power minus 1 is equals to K ML minus 1 T minus 1 raised power X L raised to power Y P over L raised to power Z. Open brackets. Then this will be written as L raised to power 3 T raised to power minus 1 is equals to K M raised to power X L raised to power minus X T raised to power minus X. Use this to open the bracket. This L raised to power Y. Then the dimension of this, the dimension for P over L is this. M L minus 2 T minus 2 or Z. So use this Z to open the bracket. This will now be M raised to power Z L raised to power minus 2Z T raised to power minus 2Z. Then the next thing, collect like terms. The like terms. So if I collect the like terms, this will still be written as L raised to power 3 T minus 1 is equals to now K M raised to power X M raised to power Z L raised to power minus X L raised to power Y L raised to power minus 2Z T raised to power minus X T raised to power minus 2Z. So we are going to collect the like terms, the same parameters we brought it out. Then we are going to, here there is no M, but here there is M. So we are going to rewrite. Then this will be written as M raised to power 0, because L raised to power 0 is 1. So L raised to power 3 T raised to power minus 1. So this expression is written as this because this M raised to power 0 is what is 1. And this will be written as M. We have 2M connected together by multiplication. It will change to what? Addition. This will be M raised to power X plus Z. Now this L, we have 3L. This will change to L raised to power. They are also connected together by what? By multiplication. So but whether we change to what? Addition. So this returns to minus X plus Y minus 2Z. Because plus times minus will give us what? Minus. That's why this one changed to this. And this T will be written as minus X minus 2Z. They are connected together by multiplication. Multiplication changes to addition. But addition, that is plus times minus, that will still be what? Minus 2Z. Then after we've done this, then relate left hand side with right hand side. Then the first one, M raised to power 0 will equals this M raised to power X plus Z. This simply shows that M cancel M, then X plus Z equals 0. Then X is equals to minus Z. Now, number 2, this L raised to power 3 will equals L raised to power minus X plus Y minus 2Z. L will cancel L, then 3 is equals to minus X, or let me say minus X plus Y minus 2Z is equals to 3. And also number 3, T raised to power minus 1 would equals to minus X minus 2Z. Therefore, would equals to T raised to power minus X minus 2Z. This T cancel this T, then minus X minus 2Z would equals minus 1. So guys, we've gotten our X to be equals to this, our this equals this equals, we've now said that if X is equals to minus Z and minus X minus 2Z is equals to minus 1, then we can substitute the value of X in this equation. So whenever we see X, we are going to replace it with what? Minus Z. So the minus here, this is the minus. This X has been replaced by minus Z. This is minus Z. Then minus 2Z is equals to minus 1. So if you solve this, your Z will equals to 1. Also, we will now say that if Z is not equals to minus Z, and we got our Z to be equals to 1, then this simply means that our X will also equals what? Minus 1. And also, if X is not equals minus 1, and Z is equals to 1, Therefore, our minus x plus y minus 2z, which equals 3, we will just substitute our x to be minus 1 and our z to be 1. So this one we change to, this is minus the x minus 1 plus y minus z, sorry, minus 2. Here is 2, this one is 2. Since our z is 1, so this is minus 2 times 1 is equals to 3. So this will now be minus times minus, that is plus 1 plus y minus 2, because 2 times 1 is still what? 2, minus 2. Now what is 1 minus 2? That is what? Minus 1. If this minus 1 goes to the other side, it becomes what? Plus. So our y is what? 4. Therefore, x is equals to minus 1, y is equals to 4, z is equals to 1. So guys, finally, if v is equals to this from the beginning of our equation, from the beginning of the equation, if v is equals to this and we got our x, y to be this, we can just substitute these parameters into this. Therefore, our v will equals to k raised to power minus 1 r raised to power 4 p over l raised to power 1. So this, which raised to power minus 1, you have to know something from the idea of indices law. X raised to power minus 1 can be written as what? 1 over x. Do you get this? So this simply means that this expression here can be rewritten as k times 1 over this, because this raised to power minus 1 simply means 1 over this, times r raised to power 4 times p over l. So therefore, our v is equals to k p r raised to power 4 over this. This should be our final answer. But you have to understand that, note, for this particular question only, are you there? K is equals to pi over 8. K is equals to pi over 8. Therefore, v is equals to pi p r raised to power 4 over 8 l. This is known as the Poiseuille formula. Now, generally, you should stop your equation, your solvings at this point. But you have to know that generally, we've already seen that this particular equation is leading to this. So further experiments showed that our k is equal to pi over 8. So you will just represent your k as pi over 8, substitute in this equation, and you will get the Poiseuille formula. Then note something. This is just peculiar to this particular question. Not all questions you are going to be representing your k as what? Pi over 8. Thank you.